In this video, we are going to be focusing on the expression of concentration in percent weight by weight, and this is given by the percentage weight by weight. The expression of concentration in percent weight by weight is calculated as the weight of the solute divided by the total weight of the solution and multiplied by 100. It is commonly used to represent the amount of the substances in a solution. The formula, let's say formula, is going to be the concentration of percentage weight by weight is simply going to be the weight of the solute. We are going to divide by the total weight of solution, total weight of solution, and we are going to multiply that by 100. Let's look at another problem. In this problem, let's say you have a solution with 80 grams of sucrose dissolved in a total solution weight of 200 grams, and we are asked to calculate the percent concentration of the sucrose in the solution. Sucrose is given by C12, H22 and 11 oxygen, and the mass here is 80 grams, and we have the total mass, let's say, of solution is given to be 200 grams. How can we solve this problem since we are asked to calculate the percent concentration of the sucrose? Therefore, the concentration in percentage weight by weight is simply going to be the weight of the solute divided by total weight of solution multiplied by 100. Between the total mass of solution and sucrose, which one is the solute and which one is the solvent? In this case, we're interested in finding the solute, and we know that sucrose is our solute. This is simply going to be 80 grams divided by the total weight of solution is 200 grams multiplied by 100. At this point, gram will cancel gram. We are going to be left with 80 divided by 200 multiplied by 100. 80 divided by 200 is simply going to be 0.4. 0.4 multiplied by 100% is simply going to be 40%. Let's try another problem. In this case, we are asked, let's say you have 50% weight by weight hydrochloric acid, which is a strong acid, HCl solution, and you need to dilute it to make 200 grams of 20% weight by weight solution, and we are asked to determine the original solution and the amount of water needed. How can we solve this problem? To determine the amount of water needed, we can use this formula C1 V1, which is equal to C2 V2. Initial concentration multiplied by initial volume, which is equal to final concentration multiplied by final volume. But in this case, we are to determine the original solution and the amount of water needed, which is the volume, which is V1. How can we find the V1? In this case, this is going to be, before then, let's bring our data here. Let's say our C1 from the data, from the question given, you have 50% weight by weight hydrochloric acid. Our C1 is going to be 50%. What about V1? V1 is unknown. What about V2? And you need to dilute it to make 200 grams. In this case, V2, that is final solution, is going to be 200 grams. What about C2? To make 20%. This is final concentration, which is 20%. Okay, let's go back to our formula. We need to find the initial volume first. C1 V1 is equal to C2 V2. For us to find V1, we are going to divide both sides by C1, which is the initial concentration. At the left hand side, initial concentration will cancel the initial concentration. We are going to be left with V1, which is simply going to be C2 V2 divided by C1. V1 C2 is final concentration and is given to be 20%. This is simply going to be 20% multiplied by V2, which is final volume, which is 200 grams. We're going to place 200 grams here, divided by initial concentration, which is what? 50%. Before you proceed, notice that we have percent will cancel percent. And at this point, you are going to be left with, that is V1. This is V1. V1 is simply going to be 20 multiplied by 200 grams. Don't forget your unit, divide by 50. If you multiply 20 by 200 grams, this is simply going to be 4,000 grams. 4,000 grams divided by 50. If you punch in your calculator, V1 is simply going to be 80 grams. Alright. Now that we have find the amount of water, we have find the initial volume, what we need to do is to find the amount of water needed. We can set the amount of water needed, we can set water needed. It's simply going to be our final volume minus initial volume. And remember, our final volume is given to be 200 grams. Initial here, which is 80 grams. This is simply going to be 200 grams minus 80 grams. In this case, 200 minus 80 is simply going to be 120 grams. And this is it for this problem. We can finally conclude and say, therefore, you need 80 grams of 50% weight by weight hydrochloric solution and 120 grams of water to make 200 grams of 20% weight by weight solution. And this is it for this problem. Let's try the last one. Let's say you're given this kind of problem where you are provided with the concentrated of sulfuric acid. Sulfuric acid is given to be H2SO4 with a concentration of 98% weight by weight. You need to prepare 500 grams of 20% weight by weight solution. And here, the available diluent is 10% weight by weight sulfuric acid solution. What are we asked to find here? We are asked to determine the volume of the concentrated solution and the diluent required. I think this is where the problems start getting more complicated. To prepare the desired solution for this kind of problem, we can use the principle of dilution, which is given to be C1 V1 plus C2 V2, which is simply going to be C3 V3. In this case, our C1 and V1 are the concentration and volume of the concentrated solution. What about our C2 and V2? C2 and V2 are the concentration and the volume of the diluent, which is what? 10% weight by weight of hydrochloric acid. What about C3 and V3? In this case, the C3 and V3 are the concentration of the volume of the final solution, which is 20% weight by weight of hydrochloric acid. Therefore, we can finally conclude and say our initial concentration is simply going to be 98%. How did I find that? from the equation, it says you have the concentration of sulfuric acid solution with a concentration of 98% weight by weight. This is our initial concentration. And you need to prepare 500 grams of 20%. The 500 grams is simply going to be the final volume, which is V3. Because here we are having 3 different volumes. V3 is simply going to be 500 grams. What about V2? Remember, the available diluent is 10%. V2 is simply going to be 10%. Sorry, not V2, I mean C2. C2 is simply going to be 10%. What about C3? C3, they said prepare 500 grams of 20% weight by weight solution. This is simply going to be C3, which is 20%. If you notice in this problem, we have C1, C2, and C3, including V3. But we doesn't have V1 and V2. They are lost. So what are we asked to find now? We're asked to find the volume of the concentrated solution, since we said C1 and V1 are the concentration and the volume of the concentrated solution. C2 and V2 are what? Are the concentration and the volume of the diluent. In this case, the volume what we are left to find is what? The volume of the concentrated solution, and V2, that is the volume of the diluent. First thing we need to do is to determine the amount of hydrochloric acid in the final solution. In this case, between C1, V1, C2, V2, C3, V3, which one is the final solution? Our final solution is going to be C3, V3. Remember, our C3 here from our data is given to be 20%. What about V3? V3 is 500 grams. So, when we said hydrochloric acid, we said what we need to do is to determine the amount of hydrochloric acid in the final solution before we can find V1 and V2. So, we can set hydrochloric acid H2SO4 in what? In final solution is simply going to be C3 V3, which is the same thing as saying C3 multiplied by V3. In this case, our C3, which is 20% divided by 100, is simply going to be 0.20. Multiplied by V3, which is the volume, which is 500 grams. This is going to remain as 500. If you multiply 0.20 multiplied by 500, this is simply going to be 100 gram. Remember, there is gram here, which is the unit. In this case, we can finally conclude and say C3 V3 is given to be 100 grams. Therefore, our C3 V3 is simply going to be 100 here. Alright, let's proceed. Let's bring back our formula, which we said C1 V1 plus C2 V2, which is equals to C3 V3. In this case, what is our C1? We said our C1, which is 50%, C1 V1 plus C2 V2 is going to be C3 V3. Let's bring back our data. Our C1 is simply going to be 98%. V1 is unknown. C2 is 10%. V2 also is unknown. But we are given the V3 to be equals to 500 grams. Also, C3 V3 is 100 grams. Let's substitute this into our data, into our formula. Our formula is C1 V1 plus C2 V2, which is equals to C3 V3.